Okay, lab 2. So the purpose was to compare an object in projectile motion and its observed trajectory with its predicted with and without drag force. So our main physics principles we used were projectile motion and drag force. And then our main result was that our proportionality constant for the drag force is equal to 0.075, and the predicted trajectory without drag force had a greater x and y final position, but the predicted with drag and observed were pretty similar. So we used the drag equation, the force of the drag above, and then we used it in our code to help calculate net force, which helped us update velocity and position using the codes, the equations listed there. We used those in the code to update the x and y position at each time increment between like each time frame. Yeah. And our system was the eraser that we threw, and our surroundings were the air and the earth. So we took a video of one of our lab mates throwing an eraser to make a little arcing motion for our projectile motion, and then we gathered data through the tracker software. So this is a picture of our video, and we used tracker software to track the position of the eraser, and it helped us calculate the initial velocity, initial position, and position throughout motion. So for experiment, we also used the starter code provided, and then we changed the initial time, the time boundary to the end of our video, and then the FNet formula to account for like gravity and also drag, and the velocity and position formulas mentioned before, and the arrows of each vector, and our mass, which we measured. So this is a picture of the code, of the parts of the code that we altered. So our initial time was 0.067 seconds because that's when the eraser started moving. And then our initial velocity was that vector found through the tracker, and initial position was also found through the tracker and was that vector. So we altered all those. And then for predicting our trajectory without drag, we set v equal to 0 instead of 0.0075. So our code output with drag and without drag are shown, and they both do have an arcing motion like our eraser, but we can see that without drag, the eraser goes more into the negative than it should because it's traveling more than with drag. Okay, so we compare the observed trajectory and the predicted without drag force and then with drag force. So these were our results. You can see all of the different lines. And the predicted motion with only gravity and no drag force does end up being a lot further than in actuality for our observed motion. And the closest we could get to the predicted with gravity and drag force to the observed was with a b of 0.0075. So in conclusion, possible sources of error could be the force of the throw to put the eraser into projectile motion, miscalculations, or an error in the drag force proportionality constant, since it wasn't exactly like our observed motion. It could differ a little bit. And for a what if question, at the same time, the velocity in the y direction will be larger because it will accelerate more, so it'll end up landing at the same time. And then what does it mean question, the model with gravity and drag does reach a terminal velocity because towards the end, the velocity becomes constant. From our output code, we can see that. It kind of levels out, which indicates a net force of 0. Thank you.